Hello, this is a video I'm making as a guide for lesser known features of Game Builder Garage, or rather lesser known techniques. There's a lot of tutorials that were already made that do not cover the things that I've been checking out. I'm pretty sure that most of you know about the whole USB mouse thing. I just wanted to make a note that most people for some reason say wireless USB mouse. It doesn't have to be wireless, it can just be a plain USB mouse like the one I got here, a little spare. Something else I do want to make note of though is the fact that you can use the keyboard. So the Nintendo Switch natively supports keyboards in general, however this game doesn't necessarily support it in a way that would be good. What I'm trying to say by that is it doesn't have keyboard shortcuts for node-ons. It doesn't have, you can't hit the delete key when you select a node-on and just delete it, or backspace, or anything. The only way you can delete a node-on is clicking this guy right here. What I'm going to do is I'm going to go through a couple of things about this game that are lesser known that you should probably know about it. So, one thing we're going to look at right now that I'm going to start off simple, that you may definitely know about, but I do want to make note of this tool, because for a long time I went without it and I did some dumb things to try to counteract this. This is a trigger from 0 node-on, and from its description, let's read this because it's very misleading. When the input changes from 0 to something other than 0, this node-on outputs a 1. Now, when I first saw that, I thought that looks exactly like a flag, because it doesn't mention the fact that it goes from 0 to 1 back to 0 very quickly. So let me quickly show that off. I got a button A here, and I press it. You see that number? Very quickly flashes from 0 to 1, but only for a single frame. They did not make that clear in the description of this trigger from 0 node-on. I wish they did. And there's something else I want to make note of with this, and that is the fact that it will not work if there is an intermediate counter or something in the middle. Let me show you exactly what I'm talking about. Here is a counter, and what it does is, on the change from 0, so when I press the button, count up once, you'll notice that it goes from 0 to 1, it flashes our guy right here, but then if I click it again, no changes. Now, to be fair, it did say that only on changes from 0. But it is something you should keep in mind. Okay, so the next piece that I want to show off is, what if I want to suddenly get this number to be a 5 all at once in a single frame, and I want to pass it through by will. Well, most of you know where this is going. Again, we're starting off very basic here, but this is what I like to call a multiply gate. And with a multiply gate, you can pass through a value through it on demand, on and off, whenever you like. What do I mean by that? Basically, take my 5 here, and I want to pass it to the 0 here, but only all at once. Not, pressing the A button 5 times or something, or multiplying our A button by 5, although that is what we're doing. But this is less about multiplying our A by 5, and more about thinking about multiply as a gate. So if I hold down A, 5 goes through, and it doesn't there. So let me move the mouse there. Hold down A, 5 goes through, let go, it doesn't. And that's simply because A outputs a 1 when it's on, and a 0 when it's off. Which means that I'm multiplying 5 by 1, it goes through. I'm multiplying 5 by 0, which is equal to 0. 0 goes through. So if you think about multiplication as a gate when you're using a 1 or a 0, that can help out in a lot of situations. So if you're ever thinking that you need a gate, you're going to be surprised how often you use that when you know about it. So the next one is going to be a little less known, and it's actually something I discovered on accident. So if I told you to add these 3 numbers together to this guy over here, one way you might do it, if you are not aware of how this game likes to work, is you would do something like this. which does get you the right answer. Keep that in mind. It will give you the correct answer. But what if I told you there was a way to do it with a lower nodon and connection count? Behold. You can simply just take all three of these and put them in the exact same adding thing. The exact same addition nodon. Even in the same point, not even across both of these, will give you the same answer consistently. And that's simply because, for some reason, the addition guy here will add up the values given to it on a singular point here. Which means that the only case where you would use both of these, you would need to use both of them, is actually if you were just adding a number with itself. Oops. Because you can't give it to it twice. You just have to do it like that. Very strange. The same things do not happen with the other ones, because with division it matters what order you put things in. You know, you can't... You know, here, I can change right here. If I want 5 divided by 4, well, that's 5 plus 4, which is 9 over 0. You know, that's just 9. So, that doesn't necessarily work out. It only generally works with addition. So keep that in mind. Okay, so the next thing I want to show off is how you do a modulo operation in Game Builder Garage. And if you're not familiar with the modulo operator, it basically goes like this. When you take a number and do modulo another number, you're basically allowing an overflow to happen, which lets the number underflow back to 0 or whatever specified amount, but most of the time it's 0. So when you're doing modulo operation, let's say that we were doing 5 modulo 3. The answer would be 2, but not because we're simply subtracting, although that is what is kind of happening. If I said, say, you know, 8 modulo 3, the answer would still be 2. And the reason why is because, let me try and work this out here. Why 8 mod 3 is 2, if you have not worked with modulo. So I'll be very quick with this. Those people who do understand modulo, this is going to seem like a very weird refresher that I'm doing. So, when I plug in 8 into 8 mod 3, I'm gonna get 2, and the reason why I'm trying to very hard to explain this is you basically, if my number is bigger than this, subtract this amount. So if my number 8 here is bigger than 3, subtract 3. What do I get? I get 5. And it's like, oh well, that's not good enough. If 5 is bigger than 3, subtract 3. What do I get? I get 2. I'm basically allowing this number to wrap around these three values until it reaches its destination. It may seem obvious, perhaps, that the counter is exactly what is made for a modulo operation. However, it was not so obvious when, you know, we were looking at this. So, excuse me if it seems a little, I don't know, like, condescending or something. But let's say I got a counter where it is looping. I'm gonna say on change from 0. And this is basically mod 11, modulo 11. Now if I press A, 3, 4, 5, 6, 7, 8, 9, 10, 11, it wraps back to 0. Now for some reason, the counter, you do have to add an extra for some reason in order to make this kind of work. The loop operation is a bit weird, but you know, that's forgivable. You know, we can just say that 0 counts as that last position. But here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, wrap back around. Now the interesting thing about this is that counters here, depending on how much input you give them, they will increase by that amount of the input that is given. So we're going to reintroduce a concept that we already talked about earlier here, which is a gate. And that's simply just to pass in the value of 5 all at once. So now, if I pass in 5, 10, I press it again, I get 3. And the reason why is because 15 mod 11 is going to be 3. Actually, is that necessarily true? Because I might start on the wrong value here. I might have had to have thought about that a little harder. But it can work. I gotta remember exactly how you set this up. But this works as a modulo operator. Very nice, very clean. Let's move on. Okay, so I would like you to take a look at exactly what I'm doing here. So this is going to be a little complicated, but this is a player here, and I'm controlling him with the analog sticks, walking on this plane. And this guy, in fact, I will color him a different color really quick. I'll make him blue. Right? Okay, so this guy's blue. And he is going to attempt to follow me. And the way I'm doing that is I have location sensors on where we are. And I'm saying my x minus his x. And that is equal to his x input. And then my z minus his z, which is equal to a z input. So basically, the higher my x is from his, the more his x will go up on the control end here. And the more my z is from his, on the right side, which is... Oh, I'm sorry, I got that flipped. But it's the same concept. So the more my x is to the right, which is positive, from him, the more he will go positive. So let's see that in action really quick. There is kind of an issue, though. As you might see, it's off-center, and also there's this issue where he's kind of slowing down at the end. Now, this could be desirable if you choose to fix this and, fix the offset. But there's actually something else I would like to take note of with this game, and that is the fact that they have these position-to-angle converters. Now, if you're looking at this, and ignoring this part, if you don't understand it, because, I don't know, it took me a while to get this one. If you're looking at this, and you're saying, this looks redundant, you're taking a position, converting it to angle, and then angle back into position. While it does look redundant, and it seems like the other one's doing the job, I do want to show a difference, and then I want to explain why it is that way. So actually, let me just disconnect these here, and move this to the side, and just slip this right here. Actually, wait, which one did I have that? I had this guy. I might have accidentally given him the wrong thing. Give me one moment, I'm sorry. Why is X registering a 1? Oh. 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 We're back in business. Okay. Take two. Take two. I'm gonna do a little dance here. Take two. Okay, I'm back. I figured out the issue. The issue is that this guy was being fed in extra inputs by these that were still existing. He would just shoot off in a random direction. I couldn't figure out why. This was the solution. It was working, and that's why. So now let me show you the difference. Before, he would slow down and there was an offset. Now, I want to show this off really quickly. There is a difference in our horizontal position. Right here. Vertical position is the same. Keep that in mind. Here, I'll show that off really quick. There we go. Vertical position is exactly the same. So, I plug that in, and it gives us 1.6, sorry, 1.60, but then check this out. Oh, 1.0 to 0. Now, why is this significant? Because what this is actually giving me is the angle difference between these two things, not the magnitude difference. So, what am I trying to say by that? Let's take my character and give him some extra speed, and this may become more obvious. This guy will always follow me at the same speed, still exactly at a perfect angle here, and he will always try to get exactly onto the same point that I'm at. It takes our position, our individual positions, and it converts them to this kind of map of XYs. And it literally tells the guy what angle, which is the position to angle function does, exactly what angle am I supposed to be facing. And then the angle to position function gives him two numbers between 0 and 1, and it always pulls it at the maximum like magnitude of those zeros and ones. And also, sorry, -1 to +1. Let me reiterate that. It always gives him the maximum like magnitude of the -1 and +1. Which means that he's always going to be moving at the same speed with no deceleration, moving towards a point at all times, even if they reach that point. So that could be a good thing, that could be a bad thing. The deceleration is useful in some cases, and there are ways to mimic that while actually getting them to always move at the same speed outside of that range. But that is the gist of it. Sorry, that took a minute to get this part working. I was so wondering what was going on with my X and my Z here. This is a case where I'm going to be moving this move marker over these bullseyes. I want you to watch what happens when I move this slowly using A, right? You see that move marker? It's overlapping between these two. I only want it to be on these states. Now, a way I could get around that is by using, when I do this counter, I don't want it to increase by, you know, like every single frame. I could have just have it gone by each individual button press. But let's say you're in a situation where you have an analog output. You have a small decimal place output coming out.
I didn't understand that.
What the fuck? So, this is where the Digitizer comes in. This is a tool I did not know a whole lot about. I'm going to show you why this thing is really cool. Now, the only setting it has is its number of stages. And what it can do is it can take an analog number, I'm calling it analog, it's really just a large decimal place. You take an analog number and turn it into a digital number. What does that mean? I'm going to try to show that off. So, now, when I hold my button here, check this out. No overlap. That's because it's taking my signal here, which is being mapped between 0 and 1, and it is dividing those steps between 0 and 1 into 5 different stages. So that means that when I scroll through this with some fine analog signal, it's going to just piece it out into these 5 different parts here. Pretty slick. I don't know. That is something new I've learned. So there's a couple of other things I want to make note of, which is that, you see the shadow quality here is not very good. It's got this like sharp edge here. Let me zoom in a little bit. I can actually shut that off a little better. Oh, it actually depends on how far out you're zooming. I'm sorry. So there is something I want to make note of, and that is the fact that the farther away objects are that exist away from the origin, the worse shadows get for some reason. And I think it's because they're saving resources in the game. They're saving all kinds of resources. Oops, I'm a little zoomed out, I'm sorry. So, maybe you can't see the difference too well here, but these shadows are a lot cleaner than they were a minute ago, because I moved a bunch of objects closer to the origin here. Now, a good example of that I'm going to quickly show off, or rather a bad example, is this game I made called Metal Cog. And I want you to note how crusty these shadows are, despite the fact that I'm pretty zoomed in. And the reason why is actually because the game takes place on the top right like quadrant of the entire map. Actually, that's more like the center. It takes place in the very top of the whole map. This is as zoomed out as I'm gonna get, sorry. Here's the origin, I placed a game screen and some math over here, but the whole game takes place all the way up here. And because all these objects are really far away from the origin, the shadow got really bad. That is a real thing that can happen in this game. Touch sensors' accuracy are supposed to be accurate to the frame. What does that mean? So let's say that I have a moving object with a touch sensor attached to it. So this is a little demo I made a while back. But what this is doing is it's taking a moving object and there's a touch sensor attached to it. Oh, I got some stick drift going on. No? Is that not stick drift? Weird. Anyways. As you can see though, actually let me explain exactly what's going on. When this touch sensor touches anything on the ground or on a wall or anything like that, it's going to teleport this blue object to it. And the issue is, sometimes it attaches it straight to the wall, but sometimes it goes most of the way through the wall before even activating this touch sensor. And for some reason, that's just how the game works. If you have a moving touch sensor, for some reason, its accuracy is questionable. Like, it's gonna act differently depending on what angle it goes at, and, you know, when it touched, what frame it touched. One last thing that I want to show off here. It's not actually in Game Builder Garage necessarily. Let me go to my I'm gonna be a little lackadaisical about this whole, you know, this whole thing here. Okay, so what I got here is a document I've been working on that basically I'm going to paraphrase here, but I want to show off at the end of this video, and I'm going to link it in the video description, which you should definitely check out. This is a wish list of problems I would like solved in Game Builder Garage, and I want this to be a resource for people who are going to be making stuff in GBG. I don't think you should be reading this through the video, but I'm going to try to explain it very simply. There are a couple of issues that I am trying to deal with. For example, this one's already been solved. A clean, simple binary to decimal converter. And someone did solve it. In fact, it was pretty easy, I won't lie. Credit goes to Sleepyhead here. And as you can see, it's instantaneous. It uses very few nodes. You can add as many digits as you want to this binary to decimal converter. Now, Sleepyhead's also been working on the opposite, which is the decimal to binary converter, which is something I proposed that we needed, but so far the best solution he's come up with is around 28 nodons for 5 digits of binary. And, you know, we're gonna make a better, more comprehensive solution available on this document. So there's some other things that are on this document. Some of them are repeats if you've listened to me talk about things that I would like figured out in this game. Things like pathfinding, or what is it, raycasting. You know, it's things that shouldn't really be possible in this game, but hey, never say never, am I right? So, let me just make sure that that is displaying correctly, yes. Some other things I would like to try to do here. These are the questions that I'm proposing, but I would like more people to propose more questions. Is a data compression algorithm, which basically takes a series of numbers and compresses it down to a single number for when you're swapping games, and this will also need a decompressor, which basically takes that big compressed number and decrypts it. So, if anyone who is watching this would like to take a crack at solving these, please check out the document, and you will have the ability to edit the document, and you can actually insert a screenshot of the solution, and you should also put in your name and maybe some description about how it was solved, because later I want to share this kind of information around with people who are trying to make Game Builder Garage games, and they will have this resource to do things like, you know, how to make a binary to decimal converter, how to do the opposite, how to make pathfinding if anyone figures it out. That's beyond the Pac-Man one that was really convenient for Pac-Man because it uses tiles, but that doesn't count. That's not what I'm looking for. If anyone figures out how to do actual raycasting, if anyone figures out how to compress a bunch of data down this pipe, a whole load of it, take a crack at those. And again, please address your own issues here, things that you want to get solved, and things that other people are going to be using in their games in a bunch of different ways, and not just single use case things. Kind of like, I won't lie, pathfinding is a bit of a single use case, but it could be useful for a bunch of stuff. So that's basically the short of it. Hope that you check out the document. I hope that you ask questions. I hope that you solve these questions, because then we will be able to make better games with fewer node-ons that look better and act better. Alright, I'm gonna end the recording here. Thank you.